Hello everyone, welcome to our tutorials on mechanics of fluids, and in this video lecture I am going to explain about discharge and continuity equation. So what do you mean by discharge and what is the continuity equation and what is the statement of the continuity equation that we are going to discuss here. So first we try to go through the definition of discharge or flow rate. So here the discharge can be also called as flow rate. So what is the definition here? It is defined as quantity of fluid flowing per unit time. Okay, a simple definition: the quantity of fluid flowing per unit time. The quantity means we can consider as a volume, or we can consider as a mass of the fluid also. So that quantity of the fluid flowing per unit time, that means within a given time how much the quantity of fluid is flowing, that is called as here discharge. Okay, and here for liquids the discharge is considered in terms of volume. So fluid is two types, already we know, liquids and gases. So for liquids the discharge is considered in terms of volume. So in terms of volume flow rate we can define the discharge for the liquids. And similarly, uh, what is the definition, sorry, what is the equation we can write for the discharge here, that we have to know. So discharge for the liquid, we can write it as from the definition, that is quantity of fluid means volume of liquid or volume of fluid divided by time. So that is volume of liquid per unit time. So that is the discharge for the liquid here. And the units we can write for this as volume means, already we know the units for the volume is meter cube and the time is seconds. So the units are for discharge. mm, Units for the discharge is meter cube per second. Okay, and similarly we try to write for gases. So for gases the discharge is considered in terms of mass. Okay, so for gases we need to consider the discharge as mass per unit time. So mass of the gas per unit time. So the equation can be written as, for discharge, discharge for gas is equal to mass of the gas divided by time. So for mass we know the kg, that is the unit, and time, second, is the unit. So the units for the discharge can be written as kg force per second, or simply we can write it as kg per second also. Okay, so that is the discharge definition and the discharge for liquid and gases. And now we try to write the equation for the discharge. So already we know discharge for the liquid is volume of the liquid per time, that is meter cube per second. So we try to modify this meter cube per second. This meter cube per second can be again written as meter square into meter per second. So here meter square, what is the to which element the meter square is the unit, means we know that for area we can write the units as meter square. Okay, into meter per second means meter per second is the unit for velocity, so we can write it as AV. So this is the discharge for the liquid, that is the volume flow rate for the liquid, which is the product of area and velocity. Okay, the product of area and velocity can be also called as your volume flow rate for the liquid. So the symbol used for discharge is Q. So that is why Q is equal to, we can write it as area into velocity. Next, similarly we try to write for gas. So discharge for the gas, already we know mass of the gas per time. So this mass of gas per time is equal to, can be written as uh, sorry, units, or units we have already written. So that is kgf per second. So kg is the unit for mass. So that mass in terms of density we can write it as, how can we write it as, the density is equal to, already we know, mass by volume. So mass is equal to, we can write it as density into volume. So that is equal to, can be written as density into volume divided by, in place of second we can write it as time. Okay, so t we can write, so that is equal to, again, so rho, q is equal to, that is again rho is density, that we can't do anything, so density into volume by time. So here volume by time is equal to area into velocity again here. So in place of this volume by time, we can write it as area into velocity. So discharge for gases can be written as rho av, density into area into velocity of the flow of the fluid here. Okay, these are the two important equations for liquids and gases to find the discharge, that is volume flow rate and mass flow rate for liquids and gases respectively. And next we try to know about what is continuity equation. So continuity equation statement. This one is the statement for the continuity equation. So what is the statement means here? From the principle of conservation of mass, the discharge or flow rate of fluids is constant even area of cross section of the flow varies. Okay, so during the flow of the fluid, if the area of cross section of the flow field even changes, the discharge is constant. Okay, that is the flow rate is constant within the flow field, even the area of cross section takes place. That is the statement of continuity equation. So we try to consider one simple diagram. So consider this is a pipe which is having varying cross sectional area. So slowly gradually the area of cross section is decreasing, and I would like to consider section 1 here and section 2 here. Okay, so at section 1 and section 2 we can consider different properties. Like here I'm considering density, area, velocity at section 1 as rho 1, a1 and v1, that is the density, area and velocity. And similarly we can consider the area, velocity, density, area and velocity at section 2 as rho 2, a2 and v2. So with the help of these two different terms or two different sections we have considered, we can write the equation from the statement of continuity. So what is the equation we can write means the discharge is constant at each and every point, even the area of cross section varies. Okay, so whatever the flow rate is going to take place at section 1, that is equal to the flow rate at section 2. That is only the statement of continuity equation here. Okay, now so now we can write the equation as in terms of mass flow rate we write. So mass flow rate formula already we know, rho av. So for two sections we need to apply, that is continuity equation. So rho 1, uh, otherwise first we try to write q1 is equal to q2. Okay, that is only discharge at section 1 is equal to discharge at section 2 from continuity equation. So q1 is equal to, we can write it as rho 1 a1 v1, that is equal to rho 2 a2 v2. Okay, so that is the uh, equation we can write from the continuity equation statement. So again for liquids, if you consider for liquids, the density is constant only because it is incompressible. So for incompressible fluids, the discharge, sorry, density is constant only. So rho 1 is equal to rho 2 we can write. So from the equation, rho 1 rho 2 it gets cancelled, and then a1 v1 is equal to a2 v2 will get, that is the continuity equation for liquids here. Okay, keep aside. Next, similarly we try to write for gases, and for gases as we know it should be written in terms of mass flow rate only. That is already we have written that because of rho 1 is not equal to rho 2, that is the density is not constant for the gases, then as it is we can write the equation in terms of mass flow rate, that is rho 1 a1 v1 is equal to rho 2 a2 v2. So this is the continuity equation for gases. When you consider the gas, we need to consider the mass flow rate. When you consider the liquid, we need to consider volume flow rate. Okay, that is the continuity equation statement. Okay, so this is about discharge definition, discharge definition of the discharge and discharge formula and the continuity equation for liquids and gases. I hope you understood. If you still have any doubts, please feel free to give a comment to my video so that I'll try to clarify your doubts. Once again, thanks for watching my video. Thank you all.